Hey there, in this short tutorial we'll try to study this extra application. So let's start solving from part number 1. Given in this circuit a battery connected across these lamps L1, L2, L3 and L4, knowing that the voltage of this battery is 8.2 volts. The first part they said that we must show the connections of the voltmeters V1 and V2 and the ammeters A1 and A2. Knowing that V1 is connected across L1, V2 is connected across L3, and A1 is connected across the branch of L1, A2 is along the branch of L2 and L3. Since the value provided by the voltmeter V1 is positive value, which is 5.4, then we must connect the positive terminal of V1 across the positive pole of the battery, and the COM terminal must be connected across the negative terminal of this battery. Knowing that the voltmeter is usually or almost connected in parallel connection. If you want to check the voltage of V2, the value is negative 3.6. Since the value is negative, then we know that this voltmeter is connected in reverse order. So the positive pole must be connected to the negative terminal of this battery, and the COM terminal is connected across the positive pole of this battery. Finally, A1 and A2. A1 is the ammeter which provides minus 120 milliampere. The ammeter must be connected in series across the circuit, and since the value is negative, the COM must be connected across the positive pole, while the other terminal must be connected across the negative terminal. Similarly, for A2, as you can see, A2 is 80 milliampere. A2 must be connected in series, and since the value of A2 is positive 80, then the COM must be connected to the negative terminal, and the plus must be connected to the positive terminal of this battery. And for the second time, the ammeter must be connected in series, while the voltmeter must be connected in parallel. If you want to move to part 2, indicate the scale. So we must indicate the most convenient scale between these scales provided. Here we have a set of values from 10 millivolts up to 200 millivolts, and for the ammeter, the scale from 100 milliampere up to 10 ampere. Let's check first what do we mean by scale. In this stimulator, you can see a multimeter. This multimeter we must connect the terminals across. Let's say here we have a resistor, and as you can see, the value is provided 39 ohms. What scale we must choose in order to use the most convenient scale? Usually we start using the highest value, which is in this case 2 mega. Since the value provided by the screen is 0, then we must choose a smaller scale, which is 200 kilos. And since we can still see 0, we must choose a smaller scale, and then the smallest scale is the correct one. So between these values, the most convenient scale is the smallest one, which is 200. How to choose the most convenient scale? Simply, if the value measured is, let's say, 39, we must search for a scale which is slightly greater than 39, or the closest one. In this case, the value is 200. So let's choose the most convenient scale for these values. In this case, we have V1 5.4 and V2 3.6. We must forget about the negative sign for now, since the negative sign represents the connection of this voltmeter. So the values are 5.4 and 3.6. Let's search for a scale slightly greater than these values. Between these values, the value 10 is the most convenient scale for, since 5.4 volts and 3.6 volts. These two values measured by the voltmeter. We need a scale slightly greater than these two values, and 10 volts is the most convenient scale in this case. For A1 and A2, the most convenient scale for the ammeters A1 and A2, the values measured are 120 milliampere and 80 milliampere. So we must search for a scale which is slightly greater than these two values. As you can see here, 100 is suitable for the 80 and 200 is suitable for the 120. As you can see here, the most convenient scale for 80 is 100 milliampere, and for 120 the most convenient scale is 200 milliamps. Moving to the next part, which is how to calculate the voltage across L2 and L4. Simply, we can see here that the value of L1 is 5.4 volts given, and this branch Mn and this branch across L2, L3, they are parallel. So if this one is 5.4, this branch will be under 5.4 volts. Law of uniqueness of voltage in a parallel circuit. To find the value of L2, the voltage across L2, simply we can subtract 5.4 from 3.6. And the answer will be, as you can see here, 5.4 minus 3.6, and the value will be 1.8 volts. Finally, to find the voltage across L4, in this case we can assume that this branch is neglected, and this circuit, which is PM, N, and N, it's a series circuit. Sorry for showing N two times, but it's by mistake. For now, in this series circuit, the voltage is additive. So if the battery is 8.2 volts, then this voltage will be equal to 5.4 plus the voltage across L4. So to find the voltage across this lamp, it's simply 8.2 minus 5.4. And the answer will be 2.8 volts. The next part, they said what is the current across L2 and the current across L4. Given the value of the current across this branch 80 milliamps, then the current is the same along this branch from M into L2, L3, and to this point. So the current across L2 will be 80 milliamps. For L4, the current will be the sum of those two values, which is 120 and 80 milliamps. So we can add up these values to know the total current passing through the main branch, which is 200 milliamps. Finally, the last question, they said what will happen if we connect a wire across the lamp L4. Simply, if we can just take a simple look at this circuit, once we connect a connecting wire across L4, and then this lamp will turn off. Okay, let's show here in this figure or diagram how can a connecting wire affect any circuit. So we'll just connect this wire across this lamp, and directly you can see that current will be passing through this connecting wire and the lamp will be off in this case. And the figure can be drawn as you can see now. So in this case, the voltage across the main battery will be 8.2 volts and the voltage across L1 will be 8.2 volts. Similarly, the voltage across these two lamps will be 8.2 volts. So simply the voltage will be higher and the brightness of these lamps will be higher than the initial case. That's all for now. Thank you.